Lesson 4-1, divisibility rules. So our divisibility rules, let's talk about the word divisible. So a number is divisible by another number if the quotient is a whole number with no remainder, and the quotient is just the solution to a division problem. So here we have 42 divided by 6, and 42 divided by 6 is 7. A whole number, no remainder. So we would say that 42 is divisible by 6. However, if we had a different problem, for example, 42 divided by 5, 42 divided by 5 is not a whole number. It is 8 with a remainder of 2, so that would be our quotient. We would say that 42 is not divisible by 5. So divisible, not divisible. Now we can use that to help us. There are some efficiencies that we can use to help us determine whether a number is divisible by another number. So some of those numbers we can determine if a number is divisible by 2 if the number is an even number. So that means the last digit is a 0, a 2, a 4, a 6, or an 8. So for example, 3,974, that 4 tells us that we have an even number, and all even numbers are divisible by 2. If it's an odd number, such as 4,973, an odd number is not divisible by 2. Our rule for 5 is if the last digit is a 0 or 5, that number is divisible by 5. So 14,875 is divisible by 5. If it was 14,870, if this were a 0 on the end, it would also be divisible by 5. However, if you had 10,000, for example, 10,897, it's not a 0 or a 5, therefore 10,897 is not divisible by 5. Another rule will be for the rule for 10, and the divisibility rule for 10 is if the last digit in a number is 0. Any number with a 0 at the end is divisible by 10. So 15,880 is divisible by 10 because there's a 0 at the end. But 11,436 is not divisible by 10 because there's not a 0 at the end. We can also have rules for the numbers 3, 9, and 6. And the rules for 3 and 9 are very similar. If we take and look at the sum of the digits, and if the sum of the digits is divisible by 3, then the whole number is divisible by 3. So here we have 225. Well, 225, if I add up those digits, 2 plus 2 plus 5, I come up with 2 and 2 is 4 plus 5 is 9. And 9 is divisible by 3. We come up with 3. So therefore this entire thing, all of 225, is divisible by 3. However, 142, 1 plus 4 plus 2 is 7. And 7 is not divisible by 3, so 142 is not divisible by 3. Similarly, when we look at 9, if the sum of the digits is divisible by 9, the entire number is divisible by 9. So here we have 684. 6 plus 8 is 14, plus 4 is 18. And 18 is divisible by 9. That's a division symbol, and that is a 9. And if we divide 18 by 9, we come up with 2. So that means that since the sum of the digits is divisible by 9, this entire number is divisible by 9. On the other hand, 89, 8 plus 9 is 17. And 17 is not divisible by 9. We end up with a remainder. So 89 is not divisible by 9. The rule for 6, if we know the rule for 2 and 3, then we know the rule for 6. The rule for 6 is if the number is divisible by both 2 and 3, then it's divisible by 6. So let's look at 72. It's an even number because there's a 2 in the end, so it's divisible by 2. And 7 plus 2 is 9, and 9 is divisible by 3, so it's divisible by 3. Therefore, 72 is divisible by 6. Let's look at 40. It's an even number, so it's divisible by 2. But is it divisible by 3? Well, 4 plus 0 is 4, and 4 is not divisible by 3. So we end up over here, no. And if it's a yes to one but a no to the other, it's not divisible by 6. It has to be divisible by both 2 and 3 for it to be divisible by 6. There's one more divisibility rule for 4. And that one is if the last 2 digits of a number form a number that's divisible by 4, the entire number is divisible by 4. For example, 6,516. The last 2 digits is 16, and 16 is divisible by 4. We end up with 4. So therefore it is this whole number is divisible by 4. 8,913, the last 2 digits are 13, and 13 is not divisible by 4. So this whole number would not be divisible by 4.